JUnit, JUnit, TDD. Marco codes. Today we're going to have a look at JUnit5. Nice and easy. Unit tests, integration tests, tests of tests. JUnit has you covered. Let's check it out. As always, I prepared a tiny sample project that we're going to use throughout this video. You'll find the sources on GitHub, the link in the references. It's a Maven project. It doesn't matter if you're using Maven or Gradle. Basically, the same concepts apply. I'm going to talk about the differences if there are any. But for now, what we're going to do is we're going to start off with the boring stuff, which means setting up dependencies. Open up the POM XML file, right? And what you would need to do now is go onto the JUnit5 homepage, read through the documentation and find the Maven dependency you need to add here. Actually, I find the homepage confusing, the documentation confusing, and I'm going to give you the shortcut, the one dependency you need to add to your project. Either go to one of the popular Maven search engines, or just in your IDE, add a new dependency, right? And you'll need to find the JUnit Jupyter dependency. Quick caveat, there's multiple JUnit Jupyter dependencies, so API, engine, params, whatever. You want to get the aggregator. You don't have to do all of that if you're using a framework like Spring Boot, which pulls in JUnit5 automatically for you. But for our case, an empty project, JUnit5 aggregator, set the scope to test here in IntelliJ, add the dependency, and don't forget to reload the Maven configuration here in IntelliJ. Wait a second till IntelliJ pulls down the dependency. You can see it's here 5A2, perfect. That's it with the boring stuff. Let's have a look at our project. We have just one class inside the project. It's a user record. User has a name, he or she has an age, the user can be blocked, and the user has a birth date. That's all there is. And we're going to write some unit tests for that user. So in good old Maven speak, you go to source test Java. Inside the same package, we're going to create a new class and call it user test class. Now, one tiny point, if you want to run those tests, not just from inside your IDE, but later on with Maven from the command line, those test classes, they need to end with either test or tests. Otherwise, Maven won't pick them up. So just call them user test. So user blah, for example, won't work. We're going to create that. We have our test class. And now let's just quickly create a new user. User Marco, right? Age still 37. I'm not blocked, and my birth date is local date now, minus years, 37 years, something like that. And we want to write some tests for that user. What you do usually with JUnit, you start writing a test method. So public void, and then let's say user should be at least 18. Something like that. There's a couple of things to watch out for now. Now, first of all, every test method in JUnit needs a test annotation. So just make sure write add test and get the org JUnit Jupyter annotation here. If you don't have Jupyter in the package name, it means you have, for whatever reason, still JUnit 4 on the class path somewhere. Kick it out. It's old, it's legacy. Just use JUnit Jupyter equals JUnit 5. We're going to add that. Second point is, there's somewhat of a style guide with JUnit5 that you write as few characters as possible inside of your test classes. You get rid of all the waste, which means get rid of the access modifiers. Public void, user should be at least, just remove the public. Same with the test class, right? I'm not saying it's a law. I'm just saying that this is somewhat of the style some projects use. And as we're talking about style already, the question always pops up. How should I name my test methods? Should I camel case them? Should I start with test that user should be? Should I maybe have underscores? By the way, I myself, user should be at least 18. I like my underscores. Again, there's no specific law. What is important is that you agree with your team members across all of your projects on the same homogeneous style. Also, you'll find a nice link to a Stack Overflow discussion on where multiple people told about their specific ways, about their experiences with how to name test methods, pros and cons, whatever. So go and have a read. Now our test isn't doing anything, but let's check out if the setup is working correctly. So I'm just going to run the test from inside IntelliJ. And as you can see, right, here's my test method. User should be at least 18. The test runner is green because there was nothing that was tested inside. So everything is fine here. Let me try something else. Let me try open up a terminal window, right? And we're going to execute Maven test here on the command line. Let's see what happens here. So as you can see, everything gets compiled. And then there's the stage where the Maven Surefire plugin runs or tries to run tests. But interestingly enough, it says tests run 0, no failures, no errors. And that is a tiny caveat, a tiny problem you have with Maven, because depending on the Maven version you're using, Maven uses old plugin versions to run tests. And those old plugin versions, they don't yet understand JUnit5. Which is why you have to go to your POM XML file. You don't have to do that in Gradle in the recent Gradle versions. You need to go to the build section. And what I would recommend you do is, first of all, make sure that the Maven Surefire plugin here is a version, I think it has to be higher than 2.20 or something. I'm just going to go with the latest one at the time of this recording, right? Maven Surefire executes the unit tests and new versions understand JUnit5. Maven compiler plugin, I'm just going to put that here because you need a relatively recent compiler plugin version if you want to work with Java 17 upwards. So I just make sure I have these both two blocks inside my POM XML file. I'm going to reload the changes. And now when I rerun or when I open up my terminal, Maven test, hopefully I should see that, yay, there was one test. Now you can see Maven detected my user test class. It ran one test method. Everything was fine, everything was green. And that is the biggest caveat to watch out for. You don't have to do that if you're using Spring Boot, for example, because they configure these plugins for you automatically. Enough with the boring stuff, let's write some tests. So, back to the user test class. User should be at least 18. A big concept of JUnit is you have assertions. Meaning what you want to do is assertions, right? And then you want to assert, you have assert true, assert array equals, assert equals. You have a couple of assert classes, essentially assert false, blah, blah, blah. So what you want to do is, for example, let's see, the user should at least be 18. So assert true that user.age greater than or equals 18. That's the assertion. Obviously, in most projects, what you do is you add a static import for the methods, for all these methods under assertions. So the test is going to read like that. We're going to run the test. And now JUnit makes sure that the user's age is obviously 18. If we put it to the user's age had to be 40 or whatever, we would get our first failure message, right? So that obviously failed. Now, the thing is, there's also assert equals, for example. So you could say assert equals user.name equals Marco, and so on and so forth. The thing is, I'm not a big fan of JUnit's assert true, assert equals methods. There's also another library you might have heard of. It's called Hamcrest. It's only slightly better. And in general, what I would advise you to do is use one very popular assertions library in combination with JUnit5. That library is called AssertJ, which means what you need to do is POM XML file. You want to add a new dependency. I'm going to make it quick. Always you'll find the reference documentation down below with the link to the project, the homepage documentation, whatever. But just for now, I'm just going to paste in the dependency you need. It's the AssertJ core dependency in a relatively recent version, which is 3.22 at the time of this recording. Now what happens? We're going to go back to our test class. We're going to delete these JUnit assertions. We're going to make sure that the static imports here are gone. And then the entry point for AssertJ is always the assertThat method. Actually, when you write assertions dot here, let me just quickly rip. There should be another import, right? Tricky. Make sure you're not importing org JUnit Jupyter API. Make sure you're importing org AssertJ core API. Right. Then you get an assertThat method, not assertThat. You're gonna put in the object inside AssertThat, and then the nice thing about AssertJ is you're now gonna have fluent assertions, which means you just write dot and you're gonna get an autocomplete. The autocomplete references methods that have to do with the object. Actually, let me not just put in the object, user.age, I'm gonna put that in here, right? And the methods I'm now getting only make sense in the context of an integer. So I'm gonna get these methods here saying, the age must be greater than or equal to, greater than, is close to, is equal to, is less than, is even, is odd, is negative, whatever. I have all these methods here. Pretty damn cool. So I would actually write something like is greater than or equal to 18, something like that. Again, make sure static import, whoops, like so. And then I could have basically, let's actually write two tests, whoops. User should at least be 18. User should be Marco. That name doesn't make sense. And that's a bigger topic, actually, how to properly, not just from the style guide, but actually how to split the tests, what to test, integration tests, unit tests. I'm going to make a separate video about that in the future. But for now, what we're going to do is we're going to say, let's see user.name. Let's try the autocomplete. And I have new methods here. For example, is my string base64 encoded? No, it's not. Does my string contain specific sequences, only digits? Does it contain a pattern, a regex pattern? Blah, 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 all of these methods. What I'm going to do is something like starts with Ma. Does my name start with Marco, right? It probably should. We're going to run that. And as you can see, two test methods, they work perfectly fine. Now I'm going to show you one more thing, which is, and now I'm just going to put it all into the same test method because I don't want to duplicate methods here back and forth. In real life, I might have separate methods here. But what we're going to do is assert that, and then we're going to say user.blocked, right? Make sure that here you write is false or is true at the end, right? Otherwise, nothing is being tested. So actually, it should be is false. And, oh no, actually, let's try with is true. So we're going to run that, and we should get an error because Marco is not blocked. As you can see, you'll get an error message saying that expecting value to be true, but was false, expected true, false. And it's a bit hard to read. And that is why AssertJ has another concept. It's called as. And let me show you how that works. So what you're going to do is you can say that user and a placeholder should be blocked, right? You're going to put in my name inside here. And then let's see what that line actually does. We're going to rerun our test. And now you get not just the expecting value to be true, but was false, true, false. You actually also get in the output a nice little error message saying user Marco should be blocked. And it kind of helps you, especially with these Boolean comparisons, it helps you quickly understand what's happening if the test method has a completely different name, for example, or it's part of a bigger test, right? And you can play with adding the descriptions. Just make sure you're not adding the description after the is true, because then it won't have an effect at all. So what we're going to do is we're going to comment this one out here and talk about one last tiny thing, because we have been talking about how to name test methods here and whatever. If you want to be passive aggressive, you don't like what your team members did, what you can always do is, instead of, changing these names, you can always add the @DisplayName annotation here. User should be at least 18, whatever. Let's see what now happens. We're going to rerun the test. And actually, you can see the only thing that changed now is the test method has the same name, and we just overwrote it here in the output in IntelliJ's test runner, also Maven's test runner, with a new DisplayName. Use that feature sparingly whenever you have a very complex name that for whatever reason you might transfer to something more human readable. Other than that, just go with a homogeneous style across your project. All right, so you can play with the AssertThat methods, try it out with your own objects, with your own types and whatnot. I'm going to show you two more things now with AssertJ. Because usually nowadays, what you also do is you want to assert JSON objects maybe, and you want to assert XML. We're going to start off with JSON. And AssertJ has a nice integration with another library which lets you do JSON assertions. What does that mean? First of all, setup, you need new dependencies. As always, you'll find them in the references. But for now, I'm just going to make it quick and easy. I'm going to paste in a couple of dependencies here. The dependency you want to be using is called JSON Unit AssertJ. It brings in the JSON Unit library, which lets you work with JSON in tests, and a bridge between JSON Unit and AssertJ. Also, you'll need a library, Jackson in my case, that converts Java objects from and to JSON, and Jackson is a popular one, also being used in Spring Boot. So you have to add these 3 dependencies here, unless you, for example, are already using Spring Boot. What can you do now? Now, when I go back to my test class, and again, I'm going to put everything into the same method, so to not have to switch back and forth between different methods and screens and whatnot, but you now have a new method. The method, actually, the class first, so there's a class called JSON Assertions. It has a method AssertThat. As always, what you can do, add a static import, so you're just going to write it like that. What you can do is, for example, put your user object, your Java user object inside that method. AssertThat. Again, fluent methods, you can have a look at them yourself. What I'm going to show you is the simplest one is equal to. Imagine we want to compare our object against a JSON string, for example. I'm just going to, put a string in here. And as you can see, the JSON string is name Marco, age 18, which isn't quite right. Blocked false is true, but born probably also isn't quite right. So we're just going to run that and we're going to see what happens, what the library, what AssertThat will actually do now. And what it's going to do is, as you can see, is it converted my user object, my Java user object, to a JSON string and said, hey, this is the actual string, age 37, right? So let's going to change that here. Blocked false seems to be fine. Birth date is a different birth date. Thank God it's not my real birth date, right? False and born, that's okay. Let's rerun our test. Whoops, no, still not working because yes, born, birth date. So what we're going to do is birth date, going to put that here. Let's rerun it. And now everything should work as expected. That is pretty cool. You don't have to worry about the ordering of the JSON properties. It will also work in a different order. But just for quick tests, JSON tests, JSON Unit, great library, check it out in combination with AssertJ, even better. Next step, we had a look at JSON. Now let's have a look at XML, right? As always, you know the drill, we need some libraries. Libraries means, let me put another library down here. As always, documentation links, whatever, in the references. The library is called XML Unit AssertJ. It will pull in XML Unit, helps you test against XML, and the bridge to AssertJ. There's one tiny caveat. The problem is the XML Unit library transitively pulls in a byte body, which is another tiny Java library. Doesn't really matter. The problem is the version it pulls in is too old to work, for example, with Java 17. So what you'll have to do again is, only if you're not using Spring Boot, for example, you have to make sure to put this block in here. References section. The block is called Dependency Management. All it does essentially, by the way, let me just delete this here, is it sets the dependency versions of transitively pulled in byte bodies to a specific new version that is able to handle Java 17. It's a lot of infrastructure code, but if you don't do that, you won't be able to run your tests, which is rather stupid. But that is everything we need, and we can finally go back to our user test class. You might have guessed correctly. Let's add a new line, XML assert, right? That's your new friend. Assert that. So compared with the JSON unit library, you now are using AssertThat again, which clashes with the AssertThat method from AssertJ, the usual one. So you'll have to put XML assert, the full name here, XML assert AssertThat. Then you could put your object inside here. You know the drill that your object will get converted to XML, whatever. I'm just going to paste in a very simple XML document in here. A has a child B with an attribute ABC. What we want to do is we want to do some XML stuff. More specifically, we want to use XPath to find out if the path A, B, and an attribute actually exists. So it's just a check, not even for the value, but just that the document looks like A with a child B with an attribute ABC. And we can call exists right here. So we're just going to run that. And we can play with that. Hopefully that worked. As you can see, everything is green. Everything is perfect. If you don't believe me, and if you're new to XPath and whatever, let me just show you a failing test. Here you can see, right, this document is not valid because there is no C child, basically, of A. And that's how you would use AssertJ together with XML Assert. Okay, we talked enough about assertions. Up next, JUnit Lifecycle. What a big word. Now, let me show you what that actually means. So you have, in general, you have test methods in JUnit. You also sometimes have the need because you want to set up a database for it, whatever, or in general, it's called setting up the tests fixture, like the user object here. You might want to run something before a test runs to set something up. And then after a test ran to, clean up stuff. And it might be that you want to run stuff, once for every test method or once for all test methods. Very simple. BeforeEach. Again, drop the public. Void setup. Right. What you can do is we're just going to say that now my user is being initialized inside that method here. And actually, I'm just going to say setup was called just to find out how often setup was called now when we run this. AfterEach. Again, void cleanup, for example. Just make sure you agree with all your teammates what those methods are called homogeneously, again, across your whole project. We're just going to set the user null, even though it doesn't make any sense here. And even recreating the user here all the time doesn't make any sense. It's always the same record, essentially. So we have setup was called, cleanup was called, and we're just going to run the whole test class. Let's see what happens. What you can see is, right, we have two test methods. So test one, test number two, and twice we get setup was called, cleanup was called, setup was called, cleanup was called, as we expected. If you just want to run it once, BeforeAll, right, makes sense. After all, tiny caveat, the method now needs to be static. Also, the AfterAll method needs to be static. Otherwise, it won't get executed. It's quite a tricky thing, actually. Now, you need to make everything static. The user static, setup, cleanup static. When we run our tests, you can see everything was only called once. And that makes sense in general for stuff like, for example, if you want to boot up a Docker container across, one test class or all the test classes, you might just want to do it once per test class, not for every single test method. Right. I'm just going to put it back to BeforeEach here. Just a bit of, exercise for you. AfterEach without static, like so. Let's continue with the cool features. Well, parameterized tests. What does that mean? So imagine you want to, for whatever reason, you have a list of friends, right? And you want to make sure that all of my friends, all of Marco's friends here, they are also at least 18. So you would write a test method like void, all friends should at least be 18, something like that. And then you could have a list of friends inside here. You could write a for loop over the list of friends and do your assertions here. The problem is it's really ugly, especially the for loops, because you're losing track if the fifth element failed inside a test. It's really tricky to understand where did something fail because of what. A much nicer way is actually to tell JUnit about the list of friends and let JUnit basically duplicate the test method for every friend and run it for every single friend. And in that case, your test output won't get jumbled up. The way you do this is, what you have to do is you have one annotation parameterized tests. The next one is to tell JUnit about the list, right? About the values you want to put into the test method. Let's start off simple. Let's imagine you don't have a list of friends, you just have a list of ages, integer ages, like so. And inside value source, you can actually put in strings, booleans, chars, doubles, whatever, arrays. So what I would do now is, I would say I have a friend who's 20, a friend who's 50, a friend who's 80. That's just how we specify the list. Inside the method AssertThat is, not ages, int age is greater than or equal to 18, something like that. Let's run it. Let's see what happens. In the output, you can see that now actually there's one big test method. All friends should at least be 18. And you get several outputs for 20, for 50, for 80. Pretty damn cool. Well, the thing is, actually with such a simple value source, it's not that cool, but I'm going to show you more sources. CSV source. What you could do is inside that annotation here, put in a CSV file. Yeah, well, it's not the greatest idea you can do for very simple CSV files by all means, but there's a different annotation, CSV file source. As you might have guessed here, you have you can specify CSV files. Thank God I have a CSV file under source test resources, right? So I'm just going to reference that, friends.csv. Let's have a look at the CSV file. It has name age, first line, Lisa 20, Hans 30, Hannah 40. Going back, I want to do one more thing. I want to skip the first line from the CSV file, and that's enough for JUnit to read in every line and create a new test method for every line in the CSV file. But first, what we want to do is string. The first column is the name of the friend. The second column is the age. Right? Name age, we have that. And we're just going to assert that age is greater than or equal to 18. Let's run our test and see what happens. Right, you can see all friends should at least be 18. There was one test for Lisa 20, one for Hans 30, one for Hannah 40. Pretty damn cool. Let's wrap it up, because the other one useful source is the built-in source is enum source. If you have an enum with 20 different values and you want to test that enum against all the values essentially, then just use an enum source and put your enum class inside here, right? Other than that, play with parameterized tests, write your own sources, super powerful, super cool. Let's take that concept one step further. Taking it one step further means creating new tests through code. Sounds crazy? It's not that crazy. You want to use another annotation at TestFactory. Isn't that cool? Every method that is annotated with at TestFactory needs to return a collection or a stream of so-called dynamic tests. These are tests you create through code that we now have to create through code. I'm just going to say dynamic tests created through code. What a crazy name for that method. So at the end of it, what you want to do is obviously you want to return your new tests. What could the possible use case be? Well, I have two XML files under source test resources, and these test files essentially users user ID 1 Marco, users 2 ID 5 Lisa. It doesn't matter. What I want to do is for every file inside here, if I add new ones, I want to create a completely new test. That's what I want to do. So what you now need to do is to read in those XML files, convert them to strings. I wrote a tiny util library. It's called resources, which you can check out in my project again, link below, which reads in those files, gives you the file name, and gives you the contents as strings, essentially, right? You can simply call it, I'm just going to make it quick. What you can do is you can say resources to strings, which will check out, the folder here. And the pattern we're going to put in is, I just want to get everything, and this is a regex pattern now. So what you want to do is users, and then whatever, some characters can be there, and it should end with XML. This gives me back a tiny helper class XML, which is a stupid class that just wraps the file name and the file's contents, right? And what I then want to do is, I don't want to return an empty list. Actually, what I want to do is I want to transform these XML files to something else. What do I need to return? Well, at the end of it, we want dynamic tests. So we're just going to go dynamic test.dynamic test. Dynamic test needs two things. It needs a display name, right? What should the test be called in that lower left corner here in IntelliJ? And then what should the test actually do? The display name is going to be the XML's name that I can just, get from my tiny wrapper object. And then the test also needs to do something which might look a bit dirty because it's essentially a nested lambda here. Before we fill in what our test should do, let's do two things. First of all, we need to return a list down here. We can delete this down here. We can actually make it look a bit nicer without the return statement here. Ooh, that's a lot of kind of crazy code. But for now, let's see what should our dynamic test do. I'm going to take a quick shortcut. What I'm going to do is I just pasted in an XML assertions, right? What I want to assert is that XML.content, the content of our XML, has an X path. You know that from before, user's user name, right? A lot of code, check it out, especially with the sources on GitHub. Make sure that the code compiles. And now let's finally fire up this test class and see what happens. As you can see, everything ran. You have, from before, the value sources, CSV file source, and normal tests. And now you have dynamic tests created through code. There's two test methods that ran. One for user 1 XML, one for user 2 XML. If we added a third XML file for now, let's just quickly do that. I'm just going to copy and paste that here, right? Like so. You should see that our user test class, when we rerun it, automatically gets a new test method. And it does. You can see it's here. That's actually super cool. So for files, network calls, whatever, database entries, maybe, depending on if you're not abusing it, it is actually quite cool to have the ability to create dynamic tests. All right, let's continue with a simpler topic, especially later on, if you want to run your tests, for example, on a CI/CD server like TeamCity, Jenkins, what have you. You want to most often split up between unit tests, integration tests, whatever. What is quite cool with JUnit 5, you just basically essentially you tag your test. You just say, this is a unit test, for example. This is an integration test. You can tag whole classes, you can tag methods, whatever have you. And at the end of it, when you're running Maven then later on your CI/CD system, you can say Maven test only the test classes that have the tag integration there, only that have the tag unit there. And I'm going to show you the commands, as always, in the references section on how to do exactly that. But it's actually a good practice to at some point start tagging your tests, especially your classes, the bigger picture, not just write tests for one year. And after a year, having to find out, what's an integration test? What's a unit test? What is that test? Yeah. So get into the habit of also correctly tagging your tests. And you can also nest, a test can also have multiple tags. You can nest them. So this is just a tiny reminder before we finish up with the last exciting topic. That's right, last topic for today. Now, what happens if you want to integrate JUnit with not just assertion libraries, but other libraries that have something to do with testing? For example, Mockito, which can mock objects, or Pack, whatever. Just different libraries, or Spring Boot, for example, also specific testing libraries. Then what you do in JUnit 5, first of all, imagine we want to integrate with Mockito. This is not going to be a video on Mockito itself. There's a new video coming out soon about Mockito. But for now, what you want to do is go to your POM.xml file, add a dependency, as always. You want to add, you'll find the dependency in the references, the Mockito JUnit Jupyter dependency. It pulls in Mockito. It also pulls in the bridge between Mockito and JUnit. What you now can do is the following. You can go back to your test class. Imagine, for whatever stupid reason, you wouldn't want to set up your user here. You want to mock your user, and in Mockito speak, you do that with an annotation called @mock. The problem is, when you now run the test, that JUnit doesn't understand the mock annotation, it won't do anything with the user, it won't initialize the user. So what you actually get here in these two test methods, you get a null pointer exception, as expected, because the user doesn't exist. What you want to do is, you want to tell JUnit, hey, have a look at the at the Mockito annotations. You do that with the ExtendWith annotation. Mockito extension.class. Make sure the import is right. And then this is enough to tell JUnit, hey, please have a look, enable the Mockito integration. If you're used to Spring Boot, for example, you would see the Spring extension, I think it's called, pack extension does. For all libraries, third-party libraries, you'll find extensions nowadays. And that's all you need to do. So when we now run this, we still get an error message. But now the error message is because Mockito wasn't able to mock our user record because it's a final class, which is absolutely fine for our use case because it tells us Mockito actually tried to mock the user for the test. So it got enabled and it actually is working. That is just the final concept I wanted to show you. Not going too deep into Mockito, into any other third-party libraries, but once you see it, ExtendWith always enables integrations with third-party libraries. That brings us to the end of it. That was the introduction into the whole JUnit5 universe. As always, you'll find further reading links in the references section down below. Other than that, I hope that was the quickest, easiest, nicest possible way of learning all the stuff, the most used stuff in your day-to-day work whenever it comes to JUnit5. Thanks for watching and sayonara.